With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/synopsys to learn more. Application security is hard when security is separated from your DevOps workflow. Security has traditionally been the final hurdle in the development lifecycle. Iterative development workflows can make security a release bottleneck. With GitLab, security is built into the CI/CD process. Every code commit is automatically scanned for security vulnerabilities in your code and its dependencies. Results are delivered to the developer in their native workflow for rapid remediation. Learn how GitLab enables DevSecOps. Visit securityweekly.com/GitLab for a 30-day free trial. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Do you always end up missing our live streams? Need somewhere to flag Security Weekly podcasts that you want to listen to? Subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list and please join our Discord server to stay in the loop on all things Security Weekly. Visit securityweekly.com/subscribe. Do you have a specific guest or topic that you want us to cover on one of the shows? Submit your suggestions for guests by visiting securityweekly.com/guests and completing the form. We review suggestions monthly and we'll reach out to you once reviewed. We want to see tons of them for 2021, so let us know. We have a final news of the week segment today, and there was one in particular, FireEye, that I grabbed because I thought it was going to be mostly just a chat about, oh, look, there is a breach and there's some nice transparency behind it. And I was looking for that angle to bring into application security bit. And then just yesterday, I believe, FireEye posted an update about what that breach actually involved. And behold, it was software supply chain. So that was pretty interesting and thoroughly in the AppSec arena. So I don't know, Matt, if or John, what you guys, how much you've seen this, or what stood out to you for this.
Well, we did cover it briefly on Enterprise Security Weekly last week when the news broke, and we knew that some of their tools were compromised. The question was, were they compromised that created the breach? Were they compromised afterwards? Because what I think FireEye did a really good job of was, one, disclosing very early, giving out all the indicators for all of their tools so people could determine whether the tools have been compromised or not. And it was very on top of this from a breach notification and educating the community. What I didn't know is where the breach actually started from. And it sounds like what you found, and I didn't read the full article, Mike, is it looks like some of those tools were breached pretty early.
Yeah, we finally do have attack ships off the belt of SolarWinds Orion in this case. And what was really interesting is that not only was their supplier, SolarWinds, which is network management tooling, but it was, as FireEye was describing, it was a very specific manually. It was a little bit unclear how this manual aspect was introduced, but essentially Trojanized, backdoored network management tools that were backdoored for a very select subset of where this software was going to. And it just so happened that, well, there, as we've also learned in the Washington Post yesterday, there were several U.S. government agencies, but also one of those targets was FireEye. And that was what was really interesting to see, is that this isn't the type of software supply chain of typo squatting, or someone gets a developer's GitHub access and they do something subtle that then is pervasive throughout every single of that point release, but just these point releases that went to very specific select targets.
That's very interesting. And SolarWinds is a very popular network monitoring tool out in the industry. And to have this well-crafted variation to target specific accounts is a really sophisticated type of attack.
Yeah,
it's
it makes
scary. It's not often I'll use the phrase scary. I'm usually fairly jaded about this type of thing, right? But as someone who tends to work at companies that are providing security software for others, or software in general for others, one of my biggest worries is something like this would hit a company where I was. Right? It's not so much. Why would someone want to? It comes back to that question people always ask: why would someone want to attack me? Why would someone want to attack SolarWinds? They're a monitoring company. Who cares about them, right? But then you think, oh, if I attack them, they're probably going to be a little bit easier and let me actually get out to my end customer I want to go, or my end target. That's the type of thing which gives me nightmares.
Yeah, and unfortunately, the other part of the nightmares is that DHS put out an advisory about this, and they put out some guidance about how to respond. And part of their response essentially says, block any external access to SolarWinds management portals, as well as re-image anything that touched what you suspect might be a compromised SolarWinds object, item. I just lost my words there for synonyms. But basically, when you have a network management tool, visibility for your network management tool means you're kind of potentially re-imaging your entire fleet.
Yeah, potentially.
So,
yeah,
a bit scary.
Yeah, because if you're using something, an agent or a different piece of technology, and that was compromised, think about all the things that potentially has access to or is monitoring that you don't want it to. Yeah, it's huge.
Yes, attack surface is dangerous here. And speaking of attack surface, I want to switch and pull out this Amnesia 33, talking about TCP IP stacks, partially because, yes, I'll admit, it's next to directory traversal vulnerabilities, flaws in TCP IP protocols are near and dear to my heart. But I think it also gives us a good setup to a handful of articles about open source security and fuzzing. So first, this Amnesia 33, it was pretty interesting. So company Forescout did some really cool research. And I think it's another great example of communication, a paper to read, just because, one, you can learn a little bit about TCP/IP, but you can also learn how to present security information. So it's a great thing to emulate if you are in the position of communicating flaws, and as well as figuring out how should I research flaws, because these researchers talk about using fuzzing capabilities. They do automated fuzzing with libfuzzer. They do some manual analysis. They also do look at pre-existing vulnerabilities, and they did their own manual code review. What was really cool is that this report also breaks down which of those, the number of vulnerabilities, which of those techniques found. And basically, long story short, if you don't want to read the entire PDF, is that everything boils down to a lack of not checking field lengths. And that leads into tons of different DOSes, but also in a couple cases, some out-of-bound reads, out-of-bound writes that get into RCEs. So really cool research coming out of Forescout there.
Yeah, I haven't gone through
a lot of good details in here, but it does set up a very good discussion for like the next two articles, I think.
Yeah, I think so. So part of this, and to set that up a little bit more, not to always blame developers here, because there's also, speaking of communication, one of the things that Forescout points out is that there's a misinterpretation or misimplementation of RSC documents that define a lot of these protocols. And so that leads, if you don't misunderstand it, you're probably going to implement it wrong. But of course, they also say that there's several aspects of the RFCs about these protocols that are poorly defined, therefore leaving some large room for error. And some of that error seeps into open source code like these IoT TCP IP stacks, but plenty of other open source code that, John, I want to throw this over to you because I think you'll enjoy how to reference the gist of this article.
Which one of you lost me in your, I just fumbled and dropped your.
Well, it was, I know this was a soul-withering waste of time, which I know also means what it's like to listen to me talk about security, but I wanted to pull you back in, John. Come back in and give us something.
Flag thrown. Yeah, no, this was, I was just reading the article and rereading it, actually. Sorry. This is the word of my tongue is dark,
Scary?
and it's sort of dark out, but yeah, dark and scary. And Linux Foundation surveyed about 1,200 open source developers, contributors, excuse me. Slight difference, but important. And really sort of asked them, a bunch of different questions around, community, security, the sort of the standard things which LF asks about. The responses on security is only 3 pages of this, I think 50 or 60 page report. But on average, 2.27% of open source development time is spent on application security. And they feel that, 2.27, they feel that the average time that they should be spending, this is across that 1,200 folks who responded, is 2.3. So they feel that's just about the right amount of time. And then, as people are giggling and laughing, the quotes, they only had a few, but the quotes from some of the folks that were mentioned here, security is a soul-withering waste of time. There's a better one, further down. It is best left for the lawyers and the process freaks, that being application security. So, and then it goes a little bit further in the LF report to actually talk about, they showed that even if they increased the spend towards AppSec, that wasn't having much of an effect. It seems like the best way to, at least the thoughts of the respondents was the best way to actually improve this, beside finding lawyers and process freaks to work on it, was to get more people doing contributing bug fixes and things like that. But I think if you take a step back and look at where it's actually the underlying thought behind what's going on here, I think what people were trying to say was they want more shift left. They want more scanning and gatekeeping happening automatically in CI/CD. And they don't want as we've been talking about this year, the 150 page report to come back at them, that then they have to get, act like that process person. Tell them what's wrong, tell them how to fix it, or just send them a pull request automatically. I think that's really at the heart of what the thoughts were on these 3 pages. But it's sort of eye-opening, definitely.
Yeah, I want to take that. Oh, go ahead, Matt.
What's so interesting is when you tie these 3 articles together, these first 3, you have a research team going out using fuzzing to identify some vulnerabilities. There's a vulnerability disclosure process to disclose these vulnerabilities. Then they go to the open source community to get fixed, and the open source community is like, we're only going to give you 2.3% of our time to fix vulnerabilities. Holy cow. Like, do you know how much stuff is running on open source these days? I mean, dark and scary is an accurate description here, because we've got these projects out there. We've got these bug bounty programs out there. We've got these disclosures happening, but there doesn't appear to be a lot of drive or value in fixing them. What does that mean to the open source supply chain long term if something doesn't change here?
Yeah, I think you're right. And I think a little bit, I will quibble a little bit with always like throwing scanners under the bus. And I don't mean this in the sense that scanners may have false positives, but it's kind of cheating to always just say, well, scanners are giving us false positives and therefore AppSec security sucks. That's just saying the counter to that is then, okay, what else are you doing besides scanners? Because as John mentioned, shifting left can also actually mean, why don't we actually design security a little bit better? And we saw this, I think, with OpenSSL back when Heartbleed came out. So OpenSSL, notoriously used pretty much everywhere, had a pretty foundational, horrible flaw in it. And then also, though, the community behind it was supporting a bunch of insecure protocols. It was supporting a bunch of obscure chipsets, things that it just didn't need. So in reaction, rather than just kind of monkey patching, to use one of the developer phrases, a couple of different flaws, some organizations came out and said, why don't we just create boring SSL or a new implementation that takes OpenSSL, gets rid of all of the old stuff that we don't need, and acknowledge that we're supporting a modern ecosystem. Let's support only the protocols that we believe the community has designated as secure or recommended to be used. And let's also get rid of a lot of the complexity of these obscure one-off chipsets that make it hard to design this library securely, and focus on making that design stronger. And you don't even need necessarily scanners to go after it. So that's where I would say the security can happen. Let's have that discussion in the design perhaps a little bit more, and move beyond the idea of just blaming the tool sets all the time.
Agreed. But you said it with the previous set of vulnerabilities, name length. How do you test for that, right?
Yes.
You throw a scanner at it, you see what happens, right? I mean, it's a good effective test, right? You're right. It may not be the only way to fix the problem, or even to identify the problem. But if the open source community also doesn't want to spend the time to fix it, I think it just creates this really interesting red flag for me around open source software and the future of open source software in a supply chain where we just saw FireEye supply chain get hacked. These are not good things to tie together, folks.
There might be some hope, though, because I will say, as hopefully our listeners will quickly remind me, I do love those fuzzing tools and LLVM sanitizers, which, John, you had another article here about, let me set you up here. Fuzzing makes finding issues easy, but then what? Which
article is this? No, I'm just kidding.
Thank you. That was fantastic.
So this one, I was hoping this was a conversation started on I think OSS security, and I was hoping it'd go a little longer than it did, but still it gave enough to sort of plant the thought of thinking it. And that thought is, we've been talking a bunch about fuzzing this year. It's I think we've got probably another article at least to go here today. Mm-hmm. I think it's fairly safe to say fuzzing has been probably in the top 5 of AppSec Weekly's things for 2020. Mm-hmm. But here's the problem: you run a fuzzer at something, you take that the BFG and you point it at your source code. You come back a day or two later and you've got this list of issues. And it's not so. This is a little bit of, in a way, of that. What we do to our developers when we say, "Here's your list of 100-page report I was just talking about." What do you do with this? From the point of view of you have to fix everything. The fuzzer has pointed out to you pretty nicely. Hey, there's you're not sanitizing input in this one particular location. Now the question becomes, not so much do you fix it. You know how to fix it. You know where to fix is, but do you report it? In other words, do you turn this into a CVE?
Yeah.
Because that requires going to a next step and actually, beside the write-up and the process and putting your name out there and saying, hey, we had an issue, but is this something actually that is, is it exploitable? Is there something hackable? That the fuzzer found something there, but is there really a there? Is it just a bug, or is it actually a security vulnerability? And that requires a lot more work. And then do you do that for every single thing? So I think it's given the security guy a bit of his own medicine in a way. And I think that's a little interesting to think about.
Yeah, that was a tough one for me, because at first I was like, well, fuzzing is going to show you a crash, a demonstrable crash. And crashes are good because that's just obviously we should fix it. But what you're really highlighting is that there's a big difference between the crash and the exploitable crash. And the exploitable crash is then, the community needs to understand, is this a CVS 9.8 or a 9.9 out of 10, as our headlines like to share? Or is this something that I can put in the further back in the backlog just because, it's not really going to be exploitable, but it's just a stability issue, perhaps?
Well, and the score depends on whether you're going to use CVSS2 or CVSS3, because calculations are different, which means different number of parameters to calculate the score. So which one are you going to use? You're going to use 3 or 2. Anyways, point well taken.
And I think, too, that I pulled in another article about Google open sourcing their Python fuzzer, which they call Atheris, which I'm very sad that they didn't use some reference to Snake Plissken. So consult me next time, Google. But in this case, one of the things that stood out to me is talking about, open source security, how can I spend more than that extra 0.06 of my time on security? Google, in this case, specifically went out of their way to actually patch in a couple different ways libfuzzer to make it work out of the box in a bunch of different environments. So this article wasn't so much about there's importance here that it's fuzzing for Python, takes advantage of some Python 3.8 that you can actually trace into opcodes to give you really fantastic coverage. But what the real good engineering work behind this is that Google just didn't say, hey, look at this open source fuzzer that works on our environment that we use all the time, and everybody can then fumble with it. Instead, they says, here's all the work we put into it, so now you can go forth and conquer with it yourself. And I think that is something that is really smart, really much more beneficial. And now we do need to see if that 2.33% of time can kick up a little bit and get this fuzzer in there for areas, obviously, where it's applicable.
Yeah, that's cool.
So there are a couple. So speaking of bugs now, there's a handful of bugs that wanted to pull out that stood out to me. Two of the, actually, I think all three of them speak to either supply chain or patching the patch. So there was one from Cisco. This is Jabber. Which I didn't set this up with our history, but for those of you interested in history of computing, tomorrow, December 15th, was the end, December 15th, 2017, I should say, was the end of life for AOL Instant Messenger, which was a messaging service that started back in 1996, I think. I just switched tab from my notes, but quite an ancient messenger. But here again is a Jabber, another messenger from Cisco, or owned by Cisco now, that has a flaw that basically had two aspects to it. One, they patched it once, then they had to go back and kind of fix the patch because the researchers pointed out that this, the patch wasn't, particularly correct the first time, and this is unfortunately a common challenge among security patches. But it's also another case where it's a universal cross-site scripting because they're using essentially an embedded Chrome browser, much like Electron apps. So it's kind of interesting to me of not only the future of open source security, are we paying attention to our supply chain? Where are we investing in security? But there's also this interesting path that developers are going outside of the security model of browsers, basically Chrome, Safari, Edge, for those of you who like living on the edge. They want to just bring a pseudo browser, but lose a lot of the updating policies, the security model of browsers, and then introduce these types of vulns, universal XSS, things go bad, and that's what I thought was interesting.
I'm just shocked that Jabber's still around. Does anybody actually use it?
That is an excellent question, because on that vein, that gives me a great segue for the Windows kernel example. This was an example of a researcher from Black Hat Europe pointing out code in the what was it called? User mode print driver. That is a user mode print driver, but sitting in kernel land. And this is code that's all the way back to Windows 7. And basically, the researcher said, hey, does anybody use this anymore? And they found out, well, even if they are, here's a whole bunch of kernel vulns now that I found. And I think that speaks to one of those aspects of how much more forceful can we be to getting rid of software? For example, Flash. This is one of the good points about 2020. Flash is dead. IE, Microsoft is making sure to kill off IE as best as possible in 2020. Maybe there's some other aspects that they could kill here, but also too, just going back to this idea of this user mode print driver in the kernel or kernel access. Maybe we should have gone back and done a different design for that and spent some money there rather than just try and patch it over time. Yeah. There then is a couple articles left, I think, at least one talking about, and this one I thought was interesting, tie back to our previous segment, Passwords. Everybody has their favorite way to get rid of passwords. And I think, and I actually just forgot if it was this year or even last year when we were talking about WebAuthn and that type of crypto-backed protocol for having, hardware tokens, your YubiKey or some type of TPM enclave on your device that's doing some cryptographic tennis between your device and a website to basically prove identity authentication. And OPAQUE here is just a kind of neat write-up from Cloudflare that is talking about one other potential way to get rid of passwords. But I do have to be a little bit skeptical if this will ever come, or anything like this will ever come to be.
Yeah, it's interesting. The last conversation I thought was kind of intriguing on the whole concept of just use certificates everywhere and authenticate once and then let the certificates do their magic, right? Here, it's passwords over TLS with WebAuthn, and it's like, yeah, is that really the right way to do it? Is that really getting us anywhere? It was interesting. I walked into the office this morning, my Google account was locked. And, I have multi-factor authentication on my Google account. So I'm like, all right, I'll re-authenticate. Well, it says I can't use your SMS token because somebody's trying to brute force the SMS. So I had to download the new Google Protect client or something like that on my phone because it's storing the key now on my phone to generate the secure code to unlock my Google account. I'm like, really? This is what I have to do to get my Google two-factor authentication working now? It's just another place to store a password.
Just another way to make your Monday better, Matt. That's what they're trying to do. But no, I think, and that highlights one of my soapboxes that I will get on around any of these movements forward in call it authentication, is how do you handle account recovery? Because if you have a YubiKey and you lose it, suddenly you have to drop back potentially to a much more brittle form of proving you should be able to get back into your account. And that might be SMS, that might just be a simple email and click on this link. So I think I think it's still great to push things forward with this, but there's still we're moving from the dangers of phishing, for example, into the dangers of account recovery and handling those workflows quite securely.
Yeah, and just to tell you, when you set up this new Google Protectant agent where it stores your cryptographic key to generate your code for two-factor, the first thing they do is, hey, do you want to buy a hardware key because you now need a recovery key? In case I lose my phone.
And you can also designate someone else to be your trusted, partner to prove who you are. So we'll nominate, as an ASW service, we'll nominate John to be the source of trust for all things authentication. I think that would be pretty good.
Yeah, I promise I'll keep everyone's passwords on a piece of paper that's not in a safe.
That is the poker
Sticky
face
note
we
on the
know and
monitor,
love from Mr. Kinsella. There is one final. I did want to go back. That's another reason I pulled out one other article here of ZDNet that is a little bit of an older vuln from November, but some proof of concept exploit code published for Kerberos, what was called this Bronze Bit attack. And I highlighted it because not so much that it's if people want to have their eyes glaze over as I talk about crypto stuff, talking about old school Kerberos and ticket granting tickets and ticket granting servers and ticket granting all kinds of things can get pretty boring pretty quick. But in this case, what stood out to me, once again, great write-up. There's a link into the GitHub description by the author as well as their blog, so you can understand GitHub, all these things. Kerberos. But what this highlights is that these tickets think of them as certs. They have an encrypted blob and they have a signed blob, much like certificates have signatures to prevent forgery. What was highlighted here is that the signature did not include that little bit of encrypted blob that someone could flip a bit from a 0 to a 1, basically. And so now an attacker could flip that bit, the signature would still be validated, and lo and behold, the attacker could get all kinds of great access that they shouldn't have had access to. So it's great to talk about Kerberos as a predecessor to, PKI infrastructure, certificate-based authentication, but definitely there's details that you don't want to mess up when you start to getting into encryption, decryption, signing them, what's being signed, and what are your boundaries of what the implementation looks like.
Which is
It's
why
funny,
whenever you have the chance to use Kerberos, don't.
Oh, it's funny because I really like Curb, and maybe it's because I've run Curb systems for, I haven't run one for ages, but for many years I did. And I don't know. I was thinking, Mike, as you're talking about that, is that why the complexity doesn't bother me? But and I think that is sort of my issue with the certs and that type of thing. It's not that the math bugs me or the TLS, that type of the details behind it, but it's actually if you make any little mistake in there, Curb particularly famously, if the timestamps are off between the two machines, that alone screws you up. Not alone worrying about everything else. So very fragile systems, and probably we're going down this path again with Kubernetes. So how do we, as back to our guest in previous half, how do we make sure that we keep things as simple and clean so that we can get the security right?
Yeah, I think that's absolutely a great message. And keeping things simple and clean, maybe we'll take that as one of our mottos going into 2021. What should we see more of, and what should we see less of? And I'm kind of curious. Matt, you sort of said maybe we should see less of, Kerberos as your authentication environment, but I know I'm going to predict you would also say we should see less of giving up root inside your containers. But I want to throw this over to you guys. Looking back over 2020 and looking forward to 2021, what should we see less of? What's one or two items on your list?
It's a good one, right? As I think about it for a second, fewer directory traversals would be kind of cool, right?
Oh, I want to see more of those. Need some news.
Less solutions that want full root access to your entire environment. That would be kind of pretty cool. Can we figure out how to secure the supply chain? That would be really, really awesome as we adopt more open source. Would love that. There's a few for you for 2021.
Yeah, you're definitely not keeping it simple for the problems. That's for sure. Those are good and complex. John, you've had a little bit to think as I throw you guys on the spot. What should we see less of in 2021?
Now that I've had a few seconds to think, I've managed to force to the back of my head the more political statements. So I'll leave those out. Or not political either way. But anyways, I think if I had to boil it down to a single phrase, how about less complexity? I think that everything we've sort of hit upon this year, if it goes from on the security side, like, Mike, that article about fuzzers and making them easier to use, Kubernetes and security and things like that we were talking about. I think there's a really great aspect there around supply chain, supply side. How do you keep that less complex? That there's so much to be done there. I think it's very easy for us as engineers and security people to think about, we're going to add all this really cool functionality and all these bells and whistles. But as Ev was saying again last half hour, how do you make it simple for the people who don't care about, like as the Linux Foundation article said, people who don't want to be the lawyers or the process folks, we got to keep those guys front of mind and try to make this stuff simple for them.
Yeah, I really like that. And hopefully also, too, we see maybe a little bit less of security being equated with just tools and security being more equated with design and making things more accessible. One of the things, too, that speaking of the Cloud Native Computing Foundation, they've been driving a effort called SPIFFY. And that, again, is also very much a certificate-based type of federated identity. And so hopefully, something, I think it's still a sandbox. I can't remember the maturity coming out of the CNCF right now. But hopefully this type of open source backing that focuses on design and usability, we do get to see a lot of that time and attention on these more interesting problems, because I would love to see less of just talking about cross-site scripting, talking about CSRF, especially a CSRF on a logout workflow. Let's kind of shrug and move on beyond those types of simple vulns into the more interesting and impactful ones that we can also start to talk about designing our ways out of.
Yeah, I think, if you think about that, you often hear me sort of sniggering or laughing at stuff on here. And I'm not so much, I'm usually not laughing at the vendors or whoever the poor bastard is who's been compromised. But I'm laughing because we're talking about directory traversal again for 20, 25 years. And it's like, I completely agree with you, Mike. It's like, how can we sort of clean up some of these basic things so that we can dig into the meatier stuff?
Exactly. And hopefully, even as we get more directory traversals, hopefully we'll still have good Vuln branding for Vulns that are worthy of branding. So let's keep those platypuses coming and so forth. Matt, you've been busy. I want to say thanks for joining us for so much. Any hints about what's coming up for you in 2021, or anything else that's a final bits of wisdom that we should share with our audience as we close out this episode?
Oh my gosh, there's lots on my plate that I have to get done, because now that we're part of Cyber Risk Alliance, there's a lot of integration across the board that needs to happen. So I've been kind of tagged to do that. So that'll keep me busy in the near term, but I can't give up the podcast 100%. I'll keep Business Security Weekly for sure. I'll fill in where I can. But I also got 4 other properties that we all have to get integrated together with a consistent message across the Cyber Risk Alliance umbrella. So that's what I will be doing a lot of the rest of this year into 2021 to help the broader portfolio. And hopefully you get to see a lot of that coming forward onto some of the shows with some new sponsors as well.
That's awesome. Yeah, that's great. And we're always going to make sure we get you on here talking as much as possible, because we also need to be able to see John playing with wire strippers and putting his life on the line as we do these sessions live. So, John, any final thoughts from you about what we can expect from 2021?
The first word that comes to mind is conferences. Starting to work on talks and ideas and things like that. But it'd be really great to see some of y'all in the flesh once again with safer conditions. So let's look forward to that.
Yes, let's definitely look forward to that, because I want to thank Matt and John, as always, for joining me virtually on these live streams. But as Matt said, hopefully we can see many of you in person at the upcoming conferences. So I just want to take a little bit of time here to say thank you once again to my co-hosts, Matt and John. Thank you, everyone who's been listening. Thank you, everyone who joins us in the Discord server live during our live streams. It keeps it entertaining, keeps us on our toes. Thank you once again for joining us. We will see you next year on Application Security Weekly.